Hello everyone, welcome to Memoneet. I am Sakti Swarup, teacher of Memoneet. I am here with a new chapter that is Electrostatics, and this is for the portion for the second test, that is Brahmastra test series. Okay, so if you have not enrolled BTS till yet, please do enroll, because we will have the question here that is completely based on NCERT and the recent previous year questions of NTA. Okay, so this will be we will expect that these questions will be asked in the Neet 2025 also. So please do enroll this test series and have a nice score in 2025 Neet. Okay. Our chapter, that is electrostatics. What do we mean by electrostatics? We have here electro and statics. Okay. So electro means charge and static means at rest. At rest. The study of charge at rest, we mean that it is electrostatics. Okay. So charge we cannot define it because it is a fundamental quantity, so we cannot define charge. What is charge? What we can just say the property of the charge. The charge of a material body or particle is the property, acquired or natural, due to which it produces and experiences electrical and magnetic effects. Okay. Charge is the body which experience electric and magnetic effects when placed in those fields. Okay. So let's say we have a body here, let's say it is positive charge. So what do you mean by this? The positive charge will be more in this body than the negative charge. So how many type of charge we have? Charge, we know that charge we have two types or three types. It is of two types. We have both positive charge and negative charge. Okay. So most of the student will tell that charge is of three types because neutral we consider as a charge. No, neutral is we consider as a body. It is not a charge. Okay, a body can be neutral. A charge can't be a neutral. Okay. So how a body can be neutral? If we have, let's say, three positive charges in the body and three negative charges in the body. So total charge here is 0 because the number of positive charges is equals to number of negative charges. So this is neutral body. Okay, neutral body. Charge, smallest charge is of charge of electron, that is 1.6 into 10 to the power minus 19. Okay, it is charge of electron. And if we have mass of electron is equals to 9.1 into 10 to the power minus 27 kg, and the proton also in the proton also the same charge is present, that is 1.6 into 10 to the power minus 19, but it is positive quantity. So mass of proton is equals to 1.27 into 10 to the power minus 24 kg. So let's say when we have a body here and one electron that is out from the body. Okay, so this body will be, what is the condition will be of the body? This body will be positive charge. Okay, and when we have body here, that is we are saying about the neutral body, and one electron we are adding up, one electron will be adding up, so this will be negative charge body. Charge q is equals to plus minus of Ne. Okay, what is n here? It is the integral multiple sorry, it is charge is the integral multiple of electrons. So this is also known as quantization of charge. Quantization of charge. Okay. Charge does not depend on velocity. Okay. Mass of particle depends on velocity. Okay, this can become as a subjective question. So m, we have the expression that is m is equals to m naught upon 1 minus v square upon c square under root. Okay, here the mass depends on the velocity, but the charge does not. See the properties of charges here. Charge is a scalar quantity. Yes, charge is a scalar quantity because it has no direction here. We can say a charge that is 5 coulomb, 6 coulomb, 12 coulomb, but we can't say its direction. So charge is a scalar quantity. Charge is of two types. Yes, charge is of two types, that is positive charge as I have discussed earlier and negative charge. Negative charge. Okay. Then mass of the negatively charged body is greater than mass of positively charged identical body. This also I have discussed. When we have body here, when we are emitting out one electron, so the body will be positively charged. Positively charged. Okay. And when we have body here and when we are adding off one electron, this body will be negatively charged. Okay. In this condition, we are adding electron. It means the mass of electron is also added. So mass of the negatively charged body is greater than the mass of the positively charged body. Okay. So charge is conserved because charge created, not destroyed. In an isolated system, charge can neither be created or destroyed. Okay. Then charge is quantized. Yes, charge is quantized because we know that charge is the integral multiple of electron. Q is equals to plus minus of n. Like point charges repel each other and unlike charges, point charges attract each other. Yes, because let's say we have two body here, body A and B. Sorry, charge A and B. Here the positive charge and positive charge, and negative charge and negative charge. These are the like charges. Okay, so like charges in the relationship will be dushmani. Okay, it means they will be enemy or enemy. So they will repel each other. But when we have the positive charge and negative charge, or negative charge or positive charge, here the relationship will be pyar. Okay, that is love in between them. So we have the unlike charges attract each other and like charges repel each other. Charge is always associated with mass. Charge cannot exist without mass, though mass can exist without charge. Okay? Let's say we have photon here, photon or neutron, sorry, photon. Then we can have neutrino. These have these charges have no mass. Okay, no relative mass. Okay, then charge is realistically invariant. Charge is neither depend and charge is not depend on the speed. Okay, so that is charge does not depend on velocity. Okay? Depend on velocity. So we can take it in any frame of reference. The charge will be the same. Okay, no change in the charge. A charge at rest produces only electric field around itself. A charge having the uniform motion produces electric as well as magnetic field, and itself a charge having accelerated motion emits electromagnetic radiation. So these are the properties of the charges. Charging of a body, charging by friction. Let's say we have two neutral body here. Let's say these are the neutral bodies, and when they are rubbed against each other, some of the charges from one body to another body it get transferred. So we can have let's say in this electron have let's say we have here the electron is donated to another body. So this will be positive charge, and which the body which have accepted the electron, this will have negative charges. So by this we can have the charging by conduction. We have conductors, that is conductors In conductors we have free electrons, much more in number. So this can the charging can be done easily here. Then we have insulators, and these have no free electrons. So charging in this charging can be done eh, can be done. And then we have semiconductors. In this we have less number of free electrons, less number of free electrons. In this we can we have to apply the temperature so that the free electrons will come out and it will be charged body. Okay. Sharing of charges. Let's say we have conducting sphere here and we connect it through the wire. Okay. So these have something potential V1 and these have something potential V2. So this V2. Okay. So the charge from one of the sphere will travel to another sphere till the potential of V1 is equals to V2. Okay. When both the spheres will have the same potential, then the conduction will stop. Otherwise, conduction will or sharing of charges will going on. By induction, let's say we have a charged body here. Here it is positive charge. Okay, and we take this charged body near to the uncharged body. So this will have due to the induction, this will have the negative charge here, so that the whole system will be neutral. Okay, so this by this we can have we can charge any body by induction. When the uh, charged charged body is kept near to the uncharged body. Okay, uncharged body. So this will be called as charging by induction. Let's now do one question here. 5 styrofoam balls, that is A, B, C, D, E, are used in the experiment. Several experiments are performed on the balls and following observations are made. Ball A repels C and attracts B. Ball D attracts B and has no effect on E. And negatively charged rod attracts both A and E. Okay. So for your information, an electrical neutral styrofoam ball is very sensitive to charge induction and gets attracted considerably if placed nearby a charged body. So what are the charges, if any, on each ball? Okay, it means it is asking that we have to find out the charges on the body. So let's see the third condition here. We have negatively charged rod attracts both A and E. Here the negatively charged rod and it will attract A and E. Okay. So here A and E can be positively charged, because they will attract, and we know that the positive and negative charge will have which type of relation, that is love, that is means attraction. Okay. So then it can be positive charge or it can be neutral. So why I am telling neutral, because if it will be neutral, then which condition will apply here, that is induction. Okay, we have discussed earlier. So let's see the second condition, that is ball D attracts B and and has no effect on E. Okay, so D and E, D, B and E. Okay. So here it is telling that it will have no effect on E. No effect means the D must be neutral and the E must be neutral, so that they will have no effect. If it will be positive charge, then it will induce negative charge and they will attract. Okay, or the vice versa. So as these both are no effect when they are kept closer. So these two will be the neutral body. Okay, then the D attracts B. Okay, D attracts B, and the first condition, that is A repels C. A is repelling C and A attracts B. Okay, it means A attracts B, and we have A can be of positive charge or neutral, but here the condition is that the A attracting B, but B is not here the neutral. Okay, B is not neutral here because the D is attracting B here. Okay, so B is attracting D. Okay, sorry, D is attracting B and A is also attracting B. So A will be positive charge and B will be negative charge. So this will be, the B will be negative charge. And what about C? C is repelling. When A and C kept closer, it repels. So it is positive charge. So we have A positive charge, C positive charge, B negative charge, then D neutral, and E also neutral. Let's now move to the next part, that is Coulomb's law or square law, inverse square law. So we know that it is defined for the electric force. So okay, the charge, the force experienced by the charge here. Okay, so let's say the force, this law states that the force is directly proportional to the q1. It means charge of one body. It is directly proportional to q2, that is charge of another body, and it is inversely proportional to 1 upon, it inversely proportional to the square of the distance. Okay, so here we have F is equals to k q1 q2 upon r square. It is Coulomb's constant. Coulomb's constant. So we have the value of k here is equals to 9 into 10 to the power 9 Newton meter square upon Coulomb square. Okay. So what is k? K is equals to 1 upon 4 pi epsilon naught. Epsilon naught is the permittivity of charge. Sorry, permittivity of medium. Okay. So permittivity of medium. Okay. So now we have F is equals to 1 upon 4 pi epsilon naught q1 q2 upon r square. We have here one charge body here and another charge body here. Its charge is, let's say, it is 2 coulomb and it is 2 coulomb, and distance between them is 2 meter. Okay, so we have force here, that is 1 upon 4 pi epsilon naught into q1, that is 2c into 2c upon r square, that is 2 square. Okay, this is how we will put the formula and get the answer of these questions. Okay, now let's say the force here, force in two charges, the two charges are always opposite, let's see how. In this particle, okay, it is positive charge and this is also positive charge, and this what will do, they will repel each other. So the charge, let's say it is q1 and q2, so the force due to q1 on q2 will be in which direction? It is away from this. Okay, and the force of q2 on q1, it will be in this direction. So force are always opposite here and equal force is there. Okay, because the force will be here F1, and here also the force will be same. Sorry, it is F1 due to 2, and here it is F force on 2, sorry, force on 1 due to 2. Okay, sorry, it is this will have force on 2 due to 1, and this will have force on 1 due to 2, and this will experience equal force, that is force on 2 due to 1 is equals to force of 1 due to 2. Okay, electrostatic force is a action reaction pair. Okay, this is why, because if we say this statement only, is it true? No, it is not true. electrostatic force is a action reaction pair along the line joining. Along the line joining. Okay. So this statement makes the complete sense, because here we have one charge, here is another charge, and the force will act along the line joining here. Either it will be positive charge or it will be positive charge, then force will act in these directions. And when we have the unlike charges, that is, it is positive and this is a negative charge, let's say, okay, the force will act in which direction? That is, they will attract, okay, but they will be always opposite of each other. So let's say what is action reaction pair? The action reaction pair properties have should be opposite in direction, then the that is force will have equal and opposite forces will be applied on the body, okay, on two different bodies, okay, and this will always act on two different bodies. So that is why we are saying that electric force is an action reaction pair, because here it satisfies all the laws of action reaction pair, okay. What is that? Is force should be opposite in direction. Yes, this is opposite in direction in these two cases. Let's compare those. We have opposite in direction, the force is opposite in direction, then equal and opposite forces, okay. Here I have mentioned that let's say it is body 1 and it is body 2. The force on body 1 due to 2 and force on body 2 due to 1 is also equal, okay. And there is two different bodies. Yes, we have first and second body, so it is an action reaction pair. And we also know, we can also say that electrostatic force is a central force, because this force will always act along the line joining of both the charges, okay. Electrostatic force is also a conservative force. This is why we are defining the potential energy here, okay. We will read in next slides. Now represent the electrostatic force in vector form, okay. Let's say we have F vector is equals to K Q1 Q2 upon R square, okay. Here it is R square. So this is the scalar form. Let's say we have a Cartesian plane here. Here we have one charge and here another charge, and it is acting and the force is acting in this direction, okay. And here it is R vector, okay. So we have, if we write in vector form, so F vector is equals to K Q1 Q2 upon R square into R cap. This will specify the direction. So R cap, we know that any let's say we have vector A vector, okay. It is A vector. Let's say we have A vector. We know that is A vector is equals to A magnitude into N cap, okay, or A cap. It is the direction and it is the magnitude. So we have A cap as equals to A vector upon A magnitude. So this is equals to F vector is equals to K Q1 Q2 upon R square into R vector upon R magnitude. So what is the value of R here? Okay, it is, let's say it is R1 and it is R2. So R vector is equals to R2 minus of R1. This is how your arrow like this and this. So we have we know that the R1 vector plus R vector is equals to R2 vector here, okay, according to this figure. So we have R2 vector minus of R1 vector is equals to R vector. So we can write here that is F vector is equals to K Q1 Q2 upon it is R2 vector R2 R2 minus of R1 whole to the power 3. Okay, because this is also magnitude, this is also magnitude, so whole to the power 3, that is R2 vector minus of R1 vector upon R2, this much. Okay, so the electrostatic force in vectorial form will be like this. Two particles having charge Q1 and Q2 when kept at a certain distance exert a force F on each other. If the distance between the two particles is reduced to half and the charge on each particle is doubled, then what will be the force between the particles? Okay, so we have here the force is, let's say force we have K Q1 Q2 upon R square. Okay, so now the radius is changed to half and the Q1 is doubled, that is 2Q1, and the Q2 is also doubled, that is 2Q2. Okay, so now the new force will be F0 is equals to K 2Q1 into 2Q2 upon R upon 2 square. So if we solve this out, this comes to be 16K Q1 Q2 upon R square. So it is 16 of the previous force. So we have F0 is equals to 16F. Okay, as we have force is equals to K Q1 into Q2 upon R square. So this is the force and it is 16 times of the force. Okay, so answer will be 16. Solve another question. A particle of mass m carrying charge Q1 is revolving around a fixed charge minus Q2 in a circular path of radius r. Calculate the period of revolution and its speed. Okay, so now let's say we have your negative charge and a positive charge is revolving around it. Okay. Positive charge is revolving around it. We have two forces acting upon here, that is centrifugal force, that is m omega square r, and the this is the electrostatic force, that is K Q1 Q2 upon R square. Okay, so we have K Q1 Q2 upon R square is equals to m omega square r. So here we have the of omega square is equals to K Q1 Q2 upon m r cube. Okay, so we know that in omega equals to 2 pi upon t, as t is equals to 2 pi upon omega, so omega will be 2 pi upon t, so it will be 4 pi square upon t square is equals to K Q1 Q2 upon m r cube. Okay, so here the value of t square is equals to 4 pi square m r cube upon K Q1 into Q2. So the value of t will be, that is period of revolution, that is 4 pi square m r cube upon K Q1 into Q2 under root. So this is the value, the period of revolution, and if you want to find out the time period, speed, v is equals to omega upon r. Okay, it's r into omega. Okay. R into omega. So omega we have find out, that is the value of omega square. So if we find out the value of omega here, K Q1 into Q2 upon m r cube under root. So the v will be r into K Q1 into Q2 upon m r cube under root. So on simplifying we can write that K Q1 into Q2 upon m r, as r square will be common here and the value of r will be cancelled. Okay, and this will be the answer for the speed also. Next concept is principle of superposition. It states that when we have two charges, okay, two charges and they will act force upon each other. Okay, if there will be present any third charge and the force on the first two charges, let's say it is 1, it is 2 and it is 3. Okay, the force of the first and second charge will not be affected because due to the principle of superposition. Electrostatic force of 2 point charges is independent of third charge of presence or absence of third charge. Presence or absence of third charge. Let's say example here. Let's say we have positive charge here and a negative charge here and another positive charge here. Okay. So we have the charges acting on, and the distance, let be it is 1 meter and it is also 1 meter. Okay. So the force of this positive charge, let's say this charge is Q1, it is Q1 and it is Q2 and it is Q3. So the force on the Q1 due to Q2, what will be it? The force on Q1 due to Q2. So K Q1 Q2 upon 1 square, and the force on of Q1 due to Q3. Force on Q1 due to Q3 will be K Q1 into Q3 upon 2 square. Okay, and the force on Q3 due to Q2, that is K Q2 into Q3 upon 1 square. Okay, so this is on the presence or absence of the third charge. So these two have the same charges, or we can have this is for the force on Q1 due to Q2, and if we write force on Q2 due to Q1, so that is equals to K Q1 into Q2 upon 1 square. The forces are not changing due to the presence or absence of another charge. So the superposition is valid for electrostatic force. Do some question here. Let's say we have a triangle. The charges are kept in the shape of the triangle. Okay, let's say here positive charge, here positive charge, and here is positive charge. Okay, so we have to find out the force on this is 1, 2, and this is 3. Okay, each of 1 microcoulomb. Okay, this is also 1 microcoulomb. This is 1 microcoulomb charge. Okay, so force on 3 due to 1, and the total force. Let's say try to find out the total force. Okay, so force net F net is equals to force on 3 due to 1 plus force on 3 due to 2. Okay, let's say it is 1 meter, 1 meter, and 1 meter. Okay, so if force on 3 due to 1 is equals to, that is K Q1 into Q2 upon R square. So 1 into 1 into 10 to the power minus 6 into minus 6, that is 10 to the power minus 12 upon 1 square. Okay, this is force due to 3, force on 3 due to 1. Then force on 3 due to 2 is equals to that is K 1 into 10 to the power minus 6 into 1 into 10 to the power minus 6 upon 1 square. Okay, so here F net will be the force. Let's look the direction of the force here. The force on 3 due to 1 will be in this direction, and the force on 3 due to 2 will be in this direction. So these have the force here is in different directions. So we can directly add this. Okay, so as force are vector quantities. Okay, we can directly add this. So what we can do, we know the vector formula. F is equals to addition of both the vectors. Okay, f1 plus f2 plus 2f1 f2 cos theta under root. Okay, this is the net force. So let's put it in this situation. Okay, so this first force will be K into 1 into 10 to the power minus 12 upon 1 square plus this one K into 1 into 10 to the power minus 12 upon 1 square plus 2 f1 into f2, that is K, this is square. Okay, this is square, this will be also square, plus 2 k1 k into 1 into 10 to the power minus 6 into f1 into f2. Okay, that is k into 1, it is 10 to the power minus 12, sorry, it is 10 to the power minus 12, and this is also 10 to the minus 12 upon 1 square. And what will be the angle between these two vectors? Okay, as this is triangle, so this will be 60 degree and this will be also 60 degree, so 2 cos 60 degree under root. Okay. This is how we can solve this type of questions. So let's say another question we will see. So we have here, it is placed in form of square in the corners of the square. Okay, so it is q1 and let's say we are taking as q. Okay. So this is q and this is also q and this is minus q, sorry, it is minus q and it is also minus q. So you have to find out the direction of the force on the center. So how can we find out? So here if we place one charge here, that is q naught, a small charge, where the force will be applied due to this q, that is in this direction. For the minus q, also for negative charge I am using blue, also in this direction, and in this the positive q, it will be in this direction, sorry, it will be in this direction as it will repel, and for the minus q it will attract and it will be in towards it. So the net force will be in the will be upwards. Net force will be upwards. Now let's say another question here. In the corners of square we are placing here q, q, q. So what will be the force on center? So now let's solve it. So the force on center, if we place one charge here q naught, the force on q naught will be due to this charge will be in this direction, and due to this charge it will repel with same amount in this direction, and for this charge it will be in this direction, and for this charge will be in this direction. Okay, so these four vectors are will be equal in magnitude, as the charge is equal and the distance from the center are also equal. So the net force at point 0 will be 0. 5 point charges, each of value q are placed on 5 vertices of a regular hexagon of side L. What is the magnitude of the force of a point charge on minus q coulomb placed at the center of the hexagon? Okay, so here we have let's say hexagon here, and here it is A, B, C, D, E and F. Okay. And in the corners we have positive charges plus q plus q plus q plus q and plus q. Okay, in the five corners one is left, and on the center we have minus q naught charge. Here let's say the center is O, the length of O and F will be L, as it is a regular hexagon. So the length from the center from each of the corner will be L. Okay, this is L, this is L, this is L. Okay, so the force acting on the center from the each of the corner will be equal. So let's say we will say in which direction it is acting. In let's say we have this force, this charge. The force acting on OB will be in which direction? In this direction. As these are two unlike charges, they will attract. And on OC will be this, on OD will be in this direction, OF will be in this direction, and sorry, OE and OF. Here all the forces are equal in magnitude. So which forces will cut down? This force and this force will cut down, as these are equal and opposite. This force and this force will cut down. So what is remained in the last? That is this force only. So we have that is K Q upon K minus Q magnitude. Okay. So minus Q magnitude is also Q. Okay. We can directly write Q. So F will be equals to Q upon L square, or we can write 1 upon 4 pi epsilon naught Q square upon L square. Okay, so this is our answer. Electrostatic equilibrium. So electrostatic equilibrium we have, let's say we have a path like this and a ball is present here. Okay, let's see here. Okay, when we take this ball to in this position, if we slightly displace ball to this position and just so the ball will will travel in this direction, and at last it will come back to its original position. So this is known as stable equilibrium. When a slight change will be done and the system will come to its original position, this is known as stable equilibrium. Unstable equilibrium, let's say we have path like this, and when the ball is present here, when we make a slight displacement of the ball here, the ball will never come back to its original path. Okay, so this is unstable equilibrium. And the neutral equilibrium is one in the straight path. If you have straight path here, the ball will if we displace the ball will move in this direction, but the ball will still be in the equilibrium position. Okay, so this is these are the different type of equilibrium. We have positive charge here and another positive charge here. Okay, and we have a negative charge, negative point charge placed at its center. Okay, now the positive charge, this positive charge will apply force in this direction, and this positive charge, second positive charge, will apply force in this direction. When we slightly move the negative charge, okay, let's say we are slightly moving the negative charge in this direction. Now the distance between the charge, that is Q1, let's say it is Q1, the Q1 and Q, okay, the distance between these two charges will be less, so the force will be more, and the negative charge will move in this direction. Okay, as the force will be more in this direction, so it is in unstable equilibrium. Unstable equilibrium, as it does not come to its original position. Okay, we have negative charge here, negative charge, another negative charge, and we are placing a negative charge in its center. Okay, so we have here the charge, the force applied on the negative charge due to this charge will be in this direction, and for this charge, for this one, will be in this direction. Okay, equal and opposite. But when we move the negative charge towards one of the negative charge side, let's say we are moving towards here. Okay, we have negative charge here, and the force will be more due to the force will be more as the distance reduces. So what it will do, it will repel more, because negative charge are the like charges, they will repel more. Okay, so as in this condition, this is a, let's say it is 2, it is 1, and it is let's say 3. Okay, so force on 3 due to 2 is more than force on portion 3 due to 1. So eventually the negative charge will move to its original position. So this is stable equilibrium. Okay, this is stable equilibrium. We complete our electrostatic force portion. Then we will start with electric field in the next class. But before that, I will tell that please buy the Elite course plan for the of the Memoneet, which have different number of questions, and you can solve any questions and ask to our experts, also to me also. You can ask anytime. Okay, so get ready for the Brahmastra test series second, and try to solve more and more questions on this. Okay, each day I will upload one lecture. Please see it and solve the questions related to these lectures. Thank you so much.